Good morning, grade 7. Last meeting, we had discussed the transmission. Okay. So again, the knocking of the door. So some of the sound from the knock passes through the door. The waves transmit or carry energy the way to the door. Okay. The energy then passes into air particles, and the person on the other side hears the knock. So talking about traveling. Okay. The knock travel from outside to the inside. Okay. So the person inside the door can actually hear the knock. What does it mean? Okay. What is the implication then? Therefore, when you knock, the sound travels, okay, the sound travels or interact with the matter that is actually in the door. Okay. Because the knock, okay, or the sound interact with the matter, tendency is there is a less or lesser sound that the second person on the other side can actually hear. That's the reason behind. Okay. Absorption. Some of the sounds is absorbed by the particles that make up the door. Instead passing through the door, the energy increases in motion of the particles of the wood. The sound changes into thermal energy within the door. Therefore, less sound energy passes into the air in the next room. Okay. The more sound that you actually generate or interact with the particles or the matter of the wood, it will actually heat up. Tendency is because there is more sound energy that interact to that particular matter, it actually creates heat now. Again, another form of energy. Reflection. Some of the energy used to knock the door reflects or bounces back into the room where you are in. Sound waves in the air transfer sound back to your ears. Okay, so when you knock, actually, it will actually bounce back. Okay, that's the reflection. Okay, the law of reflection. Let's take a look at what's with the law of reflection, because we're talking about reflection then. Okay, are you still with me?
Yes. Yes.
Okay, please ask question. Again, please turn on your camera. The law of reflection states that the angle between the incident wave, okay, and the normal is always equal to the angle between the reflected wave and the normal. Okay, it means to say that the angle of the reflection is equal to the angle of the reflected one. It's normal, or the normal angle and the reflected one, they're actually equal. So if you're going to look at this, the angle of incidence is equal to the angle of reflection. Okay, if this is the incidence, is equal to the angle of reflection, this one. Okay, let me check on the, yes, refraction. Okay, what does it mean when you hear the word refraction? To refract. To refract is to change in direction of a wave. As it changes speed, moving from one medium into another is called refraction. Change in direction, that's refraction. Okay? No other meaning. Change in direction, moving from one medium to another, that's refraction. Okay? Just like what you're actually seeing here in the example, it actually refracts. It creates now an imagery. It creates now an optical illusion that the stick is actually what? Twisted, bent?
Larger.
It's like
Yeah, larger.
bigger.
Bigger, yes. That's actually refraction. Okay? And or if you gonna put something on the on the back of the glass of water, you can actually see some changes. Like if it is in direction, it will change its direction because it refracts. Okay. Diffraction. What's with the diffraction? Diffraction is the change in direction of the wave when it travels past to an edge. If it is edge of an object through an opening, okay, it is called diffraction. Edge of an opening. Refraction is what? Changes in direction, okay? And what? What is again refraction? The one we had discussed?
Like it changes in direction.
Changes in direction, what else?
The object goes bigger or larger.
Correct. Okay. Diffraction, on the other hand, is different. This is a change also of direction, wave, but when travel pass through an edge of an object to an opening. There is an opening, okay? And if you walk in the school hall, you can hear actually sound coming from an opening of the classroom. The source of the sound. That's diffraction. Okay? The sound waves have diffracted around the corner of your ears. As you can see, if this is actually the doorway, okay, you can actually hear the sound coming out from this room. This is the room, okay? And this is the opening. So this is actually the case of diffraction. Okay? Questions?
No, sir.
Right. Let's move now to light. Okay? Light is a wave. Okay? Light waves and other forms of electromagnetic waves or EM waves differ in wavelength and frequency. So let's take a look at this one. Let's move now to electromagnetic spectrum or EM spectrum. Okay? Light is just a type of electromagnetic wave. Correct. If it is an electromagnetic wave, tendency is there is no need for a medium again to pass through. It is not a mechanical wave that needs a medium to pass through. Okay? EM waves don't need any of the medium. Okay? It can also actually move in a vacuum. Okay? Have you tried the vacuum, the one that I'm telling you last meeting?
No.
Okay, you have to try the vacuum. At least you have an idea what is really vacuum, okay, or empty space. There is a wide range of electromagnetic waves that make up the electromagnetic spectrum. What are these? Types of electromagnetic waves. The electromagnetic spectrum consists of 7 main types. These waves range from low energy, long wavelength radio waves, to very high energy, short wavelength gamma rays. The shorter the wavelength, the stronger it is. Okay. Radio waves. Okay. A low frequency, low energy electromagnetic wave that has a wavelength longer than about 30 centimeters is called a radio wave. Okay. Radio waves have least amount of energy of any electromagnetic wave. On Earth, radio and television transmitters produce radio waves that carry radio and television signals. This is where your radio and TV signals actually comes from. Okay, it came from the transmitters. Okay, the radio transmitters. Because they're using radio waves. Right? Question before we move?
No.
Okay, this is now the illustration of a radio wave. From the transmitter, okay, your radio transmitter, it will actually pass through the air and to the receiver, just like your walkie-talkie. Are you familiar with your walkie-talkie?
Yeah.
Your walkie-talkie is a two-way, okay? It could be a transmitter or a receiver. But how does it work though? It works this way, by transmitting and receiving. They have actually frequencies to follow. I have actually one of these, or actually 4. I have 4 radio phones here. You want? I will let you see. Okay, I'll let you see. Wait, I'll just get it. All right? Are you still with me?
Yes.
Okay, this is a common radio phones that we have in the market. Okay, it actually works as a receiver and a transmitter. So how does it
Of
work?
those.
Okay, turn it on, meaning to say that they are connected because they have the same frequency. So I will use one as a transmitter. One, 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 one. Power on. One. Check, test, check, check. So it actually transfers my voice, okay, the sound wave from this transmitter going to this receiver. That's how it works. Okay. Let's move now to microwaves. Wavelength of microwave is from 1 millimeter to 30 centimeters. Okay, microwaves easily pass through smoke, light rain, and clouds, which make them useful for transmitting information by satellites. Okay, weather radar systems reflect microwaves of rain or storm clouds or stormy clouds to detect the circulation and circulate the storm distance and motion. So this is the one that Pag-asa is actually using. Okay, to detect weather patterns, they use microwave. Aside from that, microwaves also are used in our microwave oven because it actually generates heat. Okay. So this is now how microwave transmission is. As you can see, there is a transmitter. Okay. And of course, receiver from 30 miles. This is actually a microwave station. Okay. Microwave transmission. This is how Pag-asa actually detects weather patterns. Light. Light is a type of electromagnetic wave that eyes detect. Okay, light spectrum. Light includes the range of wavelength. Okay, let's have infrared waves. Okay, an electronic wave or electromagnetic wave with a wavelength shorter than microwave but longer than the light is an infrared wave. Infrared wave. Okay, the sun is the major source of infrared waves. You can actually feel the infrared. Okay. However, vibrating molecules in any type of matter, including your body, emits infrared waves. We also emits infrared waves. Okay. How about ultraviolet rays or ultraviolet waves? An electromagnetic wave with slightly shorter wavelength and higher frequency than the light is an ultraviolet wave. UV wave. Okay. Electromagnetic wave with shorter wavelength carry more energy than those with the longer wavelengths and therefore can be harmful to living things. UV rays can be harmful to living things. Correct. You might have heard that ultraviolet waves or UV rays, okay, from the sun can be dangerous. It can cause skin cancer. These waves carry enough energy to cause particles of matter to combine or break apart from the other types of matter. Exposure, take note, exposure to high levels of these waves can actually damage your skin. Correct. Just like this one. We have different types of UV waves. Okay. There is UVB and UVA. Let's take a look at this. And what are the effects of this? And how far these waves can actually travel. Okay. So UVA is between 320 to 400 nanometers. It is actually larger than the UVB. The UVB is 290 to 320 nanometers. So if you're going to look at it, the UVA is more, it is actually carrying more energy than UVB. Okay. X-rays. High energy electromagnetic waves that have slightly shorter wavelength. The more shorter it is, again, the more energy it actually carries. Okay, and higher frequencies than ultraviolet rays are X-rays. These waves can be very powerful, correct? They have enough energy to pass through skin and muscle. That is why it is actually used in medical, okay, to see what is inside your body, your bones, okay? They have enough energy to pass through muscles, skin, but denser bone can stop them. So this is the reason why we are using X-rays to check on our bones, okay? This makes them useful taking pictures inside their body. Airport scanners sometimes use X-rays to take pictures of the contents inside the luggage. So this is one good example of an X-ray from the airport. Okay, it can actually see what is inside your bag. Okay, and this X-rays came from the laboratory. So this is how we actually check on the bones. Okay, as you can see in the example, there are some attached metals here in the bones. Okay, so okay, this is actually used for medical purpose. Right? Gamma rays. Ultramagnetic waves produce vibrations within the nucleus of an atom are called gamma rays or gamma radiation. Okay, they have shorter wavelength and higher frequencies than any other form of electromagnetic wave. Gamma rays carry much energy that they can actually penetrate 10 cm of lead. Imagine that. One of the densest elements. On Earth, gamma rays are produced by radioactive elements and nuclear reactions. Okay, that's how powerful this gamma radiation is, or gamma rays. It can actually cause what? Mutations. It can cause mutations. Okay, it can damage your cells. This is how gamma rays, radioactive elements are actually decomposed here, and of course, it will radiate towards us. This is outer space. This is the electromagnetic spectrum. As you can see, okay, as you can see, the more smaller, okay, the frequency is, or the wavelength, the more power it carries. Okay, from the radio wave going to microwave, infrared, visible light, ultraviolet, and X-ray going to gamma rays. So these X-ray and gamma rays are really harmful. Talking about the energy that they are actually carrying on. Okay. Light and matter interact. By the way, do you have any questions so far?
No.
No, sir.
All right, all right. If you have, please ask questions. Light and matter interact. We have transmission. A material that allows almost all the light striking it to pass through and to which object can be seen clearly is transparent. Yes, just like your glass. It is transparent. You can actually see what's behind the glass, correct? You can see it clearly. A material that allows most of the light to strike, but not all, to pass through, but through which object appear blurry, is called translucent. Just like your jealousies. What else? Your tainted glass. Okay? Those material allows most of the light, but not all. Okay? That's translucent. Transparent, translucent. Okay? Next, absorption. Some materials absorb most of the light that strikes them. Okay? They transmit no light. Therefore, you cannot actually see objects through them. Okay? The material in which light does not pass through is an opaque. Okay? An opaque. Have you seen a room which actually they can actually see you, okay, but you cannot actually see them? Other
Yeah.
mirrors is using this. Okay? So they call it double mirror. Okay? The double mirror, you can actually see them, but they cannot actually see you. Other also tainted glass in houses and cars do this the same, no? They absorb more light, okay, because it is an opaque. They absorb more light. They didn't actually they transmit no light. Therefore, you cannot actually see them inside the car or inside the house. That's opaque. Okay. So this is now the comparison. This is transparent. Okay. So you can see all of the light is reflected. You can actually see what's behind. Okay. The wall. The second is for the window. The second is translucent. You can actually see some because this is blurry and this is translucent. It will not allow all the lights to pass through and it will not reflect backlight. Opaque, on the other hand, is different. It absorbs all the light, therefore you cannot actually see something on behind. Okay. Reflection. Okay, recall the waves reflect off surface according to the law of reflection, which states that the angle of incidence is equal to the angle of reflection. Okay. Parallel rays that reflect from a smooth surface remains parallel and form a clear image. Okay. Light that reflects from a bumpy surface scatters in many directions. A wall seems smooth, but up close it's too bumpy to form a clear image. Okay. That's reflection. It will not actually reflect if there are some bumpy, bumpy area or bumpy surfaces, okay, in that certain surface, right? So it only reflects, okay, it only reflects, waves can only reflect if there are some smooth surfaces. This is the reason behind why studio, okay, studio like the working studio for music, they tend to put something on their wall. Okay, if you can observe, if you have gone into a recording studio, their walls are composed of rough surfaces. This is to prevent what? Reflection, reflecting of sound waves. The more bumpy it is, the more what? The more it is to be clear for the sound because sound will not reflect. Color. Colors. The colors of an object depend on the wavelength of light that enters your eye. Okay. Opaque objects. Suppose white light strikes Philippine flag. Okay. The blue panel absorbs all the wavelength of light except for the blue, because that blue reflects on your eye. Okay. The blue wavelength reflects back into your eyes. Okay. The red panel absorbs all the colors except for the red. Okay. The red reflects now back to your eyes. This is how our eyes work. This is how we see colors. The yellow stars, including sun, absorbs all the colors except for yellow. And yellow reflects into your eyes. Okay. The white triangle reflects all the colors you see. White. If you can actually see white, those are all the colors reflected in your eyes. An opaque object is the color it reflects. Okay, let me check on the duration of this presentation. Okay, let's stop with opaque objects. Okay, let's continue by next meeting. Since we have a limited time now, we still have 9 minutes, but this is not enough for us to discuss more about this. And we had done a lot. Do you have any questions so far with the discussed topic?
What is a diffraction?
Okay, diffraction. If there is refraction, depending of waves, diffraction is the scattering, okay, and looking for what? An area to spill. If you're going to look at diffraction here, that's why I'm telling you to ask questions every now and then so that we can address your concerns. Let me go back to the slide. Still the same, it changes in direction of a wave. It travels past to an edge. Okay, just like this, if you're going to look at the door, okay, the sound came from this room and it diffracted outside. So it
Okay.
needs to be what? An exit of sound. That's diffraction. Okay. Refraction, on the other hand, is bending. Okay. A change of direction at faster speed, moving from one medium to another, or shall we say, a concrete word is bending. The bending of light, the bending of sound, the bending of what? Electromagnetic waves. That's refraction. Okay. Diffract is to change in direction, but with a particular what? Edge. That's diffraction. Okay. What else? Any other question?
No.
All right. How about others aside from RJ's question?
No.
No.
All right. Levi. Kaizel is around.
No.
Kaizel, are you taking this online or modular? Stadillo? Okay. Let's continue by next meeting. Hopefully you learned something from our simple discussion. And have a nice day, grade 7. Take care. Bye-bye. Have a nice day.